Okay, so this is Unit 3 of AP Physics C Mechanics. It's work, energy, and power. It's a pretty important unit, but there's also not that much you have to know. It's a pretty conceptual chapter, I would say. So let's get into it. So, energy is the ability to do work, and it cannot be negative. It's a scalar quantity. So, the first type of energy that we're going to look at is translational kinetic energy. So, as you would assume, it has to have like some kind of kinetic movement going on, and that's why it has like a velocity in their equation. So 1 over 2 multiplied by the mass multiplied by the velocity squared. As you would assume from that, the kinetic energy is different for different spotters because the perceived velocity is different for different spotters, as we mentioned in Unit 1. So, the work done by something is the energy put in and out of a system by a force over a distance. Both force and distance is quite important, and you would have that equation. Work equals force multiplied by distance or displacement. This is important because we usually we need to take those things as two different entities. That's kind of important because we're going to talk about conservative work and non-conservative work. So conservative work is dependent on the displacement. And why is this important? Because, for example, for circular motion, if I move and I come back, there is no displacement. We're in the same spot. So there wouldn't be any conservative work done on that system. But contrary to that, non-conservative work, for example, friction, drag force, that depends on the path/distance traveled. So if I moved around a circular pathway, friction would still be a thing. Just because I came back to the same place doesn't mean that there is no heat lost by the friction. Kind of a good example that I said for here is this. So a block moves up and then the block moves down again in that same position. So because there is no change in position, the conservative work is 0. But the non-conservative work is over 0 because it's scalar. Because distance is added for the friction. So there is non-conservative work done, and therefore there is heat lost by the friction. So another important thing is that for getting work, you have to think about force only in the direction of the displacement, or displacement only in the direction of the force. So that's why we have this equation, where force multiplied by cosine theta between the force and the displacement, because we only want the force or displacement in which it is in the same direction. So yeah, let's say that's force, and then that's displacement, or distance, or whatever you want, and cosine the force. So you would get that amount of force contrary to that other one in the y-axis, and then you multiply by that thing with the distance. I'm sorry, this makes no sense. Another important thing is that kinetic energy, the change in kinetic energy is work. Another thing that we would like to mention is because force and distance multiplies to get work, you can get work through graphical ways. So the area under a force over distance graph is work because you multiply force and distance to get work.